If you've ever created more than one table, you've probably seen these. These are broken references. They appear when you delete a row that was previously selected here. Now, if you deleted those rows accidentally, you still have time to restore them. But if 12 hours have passed, they will be gone for good, so you will have no other choice than to clean them up. Of course, you can do it manually, going cell by cell and checking these. Or you can automate it with a button. In this short tip video, I will show you how to deal with that. Let's go. Okay, to automate the cleanup, we need a button. There's two ways how we can do it. The first and most straightforward is to add a button to the table. Then we can configure it to modify the row it's in and remove all the broken references from it. And then we can have one button to click all the buttons in the column. However, and I'm saying this in my next video about buttons, this has more to do with the maintenance of the table and not really with working with rows. So for each of such cases, should you really create another column in the table? No, because when you have too many columns, it gets harder to work with the table. Besides, there is a limit on the number of columns you can have. So I wouldn't do this. I would just go and create a button outside of the table. And now it's time to write the formula. Yes, the formula, because first, with the UI settings, you cannot modify rows individually. You can only set the whole column to the selection of tags, and this is what it does. It would just update all rows in a table to the single tag, not each of them individually. So that's why you have to make it a formula. And second, because I strongly encourage you to build up the habit of using formulas all the time and not rely on UI settings. The reasons for that I'm giving you in the next video about buttons. So let's write our formula and I'll explain it when I'm done. And let's see if it works. And it does. So let's dive into the formula. Let me explain what is happening. First, we take a table of contacts, and then we use for each to iterate over each of the rows in this table individually. We could have narrowed the list of rows to only those that have these broken tags, but for the simplicity of this demo, let's just run it on the whole table. So what for each does is that it takes a collection of elements as an input and then applies this part of the expression onto each element individually. So if there are 10 contacts, this part of the formula will execute 10 times. And now, so that it can execute each time on a different row, this formula also gives us the current value variable, which in each of those 10 times will point to a respective row, the first row, the second row, the third row in the collection, and so on. This is what current value is for. What we do next, which is optional in this case, but I like to do it nonetheless, is we store the current value into a variable named contact. This is just my principle that whenever I have a for each loop, even if I don't have nested loops, I take current value and give it a sensible name. Because for me this is already a muscle memory thing and it's just faster to do it rather than whenever I do need to create an internal loop, get back to it and replace all the current values with a named variable. And now with each contact we modify it individually. And this is something that you can only do in the formula and not with the UI like I showed you in the beginning. So with each contact row we modify its tags cell with the content of the tags cell, but with all the broken items removed with a filter. Filter and for each are both the formulas that loop over collection to do something on each element. That's why you see another current value here, which is not the same as the current value there. So it takes each tag or what used to be a tag and checks if it's a row in a table tags. And if it's not, this expression returns false and the value is not let through the filter. So the value of this thing that we insert in the tags cell now consists only of the elements that are really rows from the table tags. Now, why do I have this part in the chain? This is because we may have contacts that don't have any tags. And because of a recent change in Coda, when you have an empty list of tags, it's not stored in the table as a list, it's stored as an undefined value. And filter can only run on lists, it expects a list as an input, not a blank value. So if we remove this part and run the button, you will see that it will encounter the first row without any tags and will fail at that moment. So that's why we need to keep it in here, so that if a value is blank, we still give a filter formula a list. Okay, a bonus tip for you. What if you didn't intend to remove those tags in the first place, but it's already too late to restore them? Let's see how we can add the tags again and restore them with another button. So I go here and I add friend tag, and an emoji, and I add the Matt at a picnic tag, and add the camping emoji. And I copy this button and adjust our formula. Now, instead of removing the tags that are not in the tags table, we should actually replace them with the matching tags from the text table. So instead of filter that will remove items that don't pass the filter, we shall now for each incoming tag either return itself if it's the valid one, or find something else. Now let me modify the formula, and again I'll explain it after. And this time I'll go into the big screen mode. This just bothers me a lot, how Coda cannot detect that it's a single row actually from the list, not a collection of rows. They did mess it up a little bit in their relations update. I can add first here just so that the formula editor doesn't complain, but it does nothing in this case, it's still just one value incoming. So this is our final formula. Let's see if it works. Voila! Now let's dive into it. First, I replaced the filter with the for each. That's because this time we don't just need to throw out items. For each item in the incoming list, which contains both valid and invalid tags, we need to either return itself if it's a valid tag, or try to find a corresponding tag if it's not. And that's exactly what this for each does. For each valid or broken tag, it makes a check whether the tag is from the table of tags. If it is, it just returns the tag. Otherwise, it looks through the table of tags and tries to find the tag that corresponds to this broken tag. Now, when this is a broken reference, all we can do with it is convert it to text to get this value that's displayed in the great disabled chip. Trying this will just not work. You cannot read any column from a broken reference. And when we find a match, we just return it as the first item of the resulting list. As you may or may not know, filter always returns a list even if it's just one item. Finally, this is the idiom that I put pretty much every time I do any list modification. This makes sure that the list is flat, there are no lists of lists. Then I remove the duplicates if there are any. And finally, if I accidentally mix in a blank value, like some of the tags didn't exist anymore and the filter just returned blank, I just remove the blanks. Take another look at this formula, because even though I intended to make this a simple episode, I still ended up showing pretty much the whole action framework in just one demo. Here we have both the looping and conditionals and making variables with name, so yeah, task failed. That said, I will have some simple episodes in my queue, because beginners also deserve good tutorials. And if I ever say that some piece of knowledge is below me, then I'm a bad teacher. Thank you for watching, please like, subscribe, check out my Patreon, and I'll see you in the next video, which is gonna be the bomb. A few follow-up points that I have the luxury to amend in this video because the launch postponed by a few days. First, I said that in 12 hours deleted rows that still have references to them will be deleted for good. Well, it's not like the clock strikes 12 and the carriage turns into a pumpkin. What I meant to say was that rows were guaranteed to be kept for at least 12 hours. And after those 12 hours, whenever the next garbage collection cycle kicks in, they will be gone. That's why the next morning I checked on my dock, I could still restore the row. I thought maybe this information was obsolete because I got it from a Coda engineer 4 years ago. But no, I checked in a few hours and the row was gone. Which gets us to point 2, the thing that I totally forgot. Coda actually gives you a simple way to create the missing row. It's there at the click of the button, it will automatically fix the broken references for that row. So was all that trouble of setting up the second formula in vain? No, because this only works if the table is local. If your tags come from a sync table like a crossdock, you'll still have to go through all that trouble of relinking yourself. So it's good to know after all. Besides, that was a practical and powerful demo. Oh, and one more thing about those times when I was typing out the formula in real time. I didn't cut it out or speed it up on purpose. I wanted you to watch and follow along, anticipating what is that I'm gonna type next. And if you wanted to skip forward, I included the progress bar so that you know how much you should skip. Please let me know in the comments if this is helpful and I should keep doing this, or I should just cut it out the next time.